Alrighty, so in this problem, we're gonna do 8b from page 8, exam number 3, in relation to related rates. So this is gonna be a word problem, which refers to a man is flying a kite. The kite is 150 feet above the ground, and the wind is blowing it horizontally away from him at a rate of 5 feet per second. Well, at what rate is he letting out the string when the length of the string is 170 feet? So when looking at these kinds of word problems, and especially with related rates, so you want to look at the givens that you have. So we have a given that the rate at which the kite is being horizontally blown away is 5 feet per second, and we're asked to find the rate that he's letting out the string when the length of the string is 170 feet. So first, what I like to do is write down the givens and also try to visualize the problem in such a way that enables us to find the formula and therefore solve for the variables that we're asked for. So in this case, I think given that the scenario is a man flying a kite, I think we can draw a right triangle in this case, just like that. And then what we're given that the kite is 150 feet above the ground. So 150 feet right here for y, and this is going to be x, and then this is going to be z right here. So x, we're not really given the x, but we're rather giving the rate at which x changes. So in this case, this is dx dt, which equals 5 feet per second. And then now we have z, but we don't have a given initial z. We only have a z when the length of the string is 170 feet. So when we're asked to find the new rate. So in this case, we're trying to find dz dt when z is 170 feet. So in this case, given that we have a right triangle, we can use the Pythagorean theorem, which is x squared plus y squared equals z squared. I mean, typically it's a squared plus b squared equals c squared, but in this case we use different denominations for the variables. So in this case, instead of having the base variables that we're used to, we're just going to have x squared plus y squared equals z squared. So in this case, what we want to do first is we want to find x in this case. So what we can do is we can use the information that we already have in terms of the y and the z to find x. So we can rewrite this as x plus 150 squared equals 170 squared. So now we do the math, so we do x squared plus 150 squared, so 150 times 150, that would be around 1500, so 1500 times 50, so that would be about 2250, give or take, and then 170 squared, that would be about how much would that be? 170 times 170, so 170 times 100, that is 1700 times, then you have 170 plus 70, so that would just be sorry, this is actually shouldn't be 2002, it should actually be 22,500 equals 170 times 100, so that's 17,000, then 170 times 70, and be 1700 times 7, which would be about 3,500. It's 11,900. So 17,000 plus 11,900. That should be about 20,900. So now we do the math. So x squared equals 6,400. So now we take the square root of that on both sides. So x should just give us 80 in this case. So x will just be 80. So just like that. And then now we can start plugging those in. But before we plug those in, we actually want to find the derivative of this formula right here and rewrite it in terms of in relation to time in order to find the rates. So when finding the derivative in relation to time or in relation to or with related rates, you want to make sure that when you find the derivative, when you apply the parallel, you also write down dx dt. So for example, when finding the derivative of this function, it would be 2x dx dt, and then this would just be 2y dy dt equals z squared, which in this case it would be like 2z dz dt. So this would be the typical way to find the derivative of like these types of formulas, like when it comes to the Pythagorean theorem or when it comes to other formulas in relation to geometry, especially when it comes to related rates. But since we want to first introduce the 150, plug that into the y over here, just to make sure we start with the initial values that we had. So because we had the x and z's unknown at first, so what we want to do is we want to find that derivative. So it would be x squared plus 150 squared equals z squared. And then now we find the derivative. So this would be 2x dx dt plus 0, because the derivative of a constant is always going to be 0 no matter what. And then you have 2z dz dt. So now we can start substituting in or plugging in the values that we already found out. So in this case we have 2 times x, which is 80, times dx dt, which is 5 in this case, plus 0 equals 2 times 170, which is z, times dz dt, which is unknown, which is the variable that we're trying to look for in this case. So now we apply it. So 2 times 80 is 160, and 160 times 5 is 160 times 5, that should be 900 in this case. What we can do actually first, to like even simplify it further, is we can cancel out 2 of the 2's, both 2's, because we have 2's on both sides of the spectrum here, or we can just plug them in just like that and see what happens. In this case, we have 880 times 5, which is 400 times 2, which is 800. So 800 equals 340 dz dt. And now we can reduce this in terms of 2. So we can reduce this to 400 to 170, just like that. And then we can reduce these even further in terms of tens. So don't forget the dz dt. So we can just do 40 equals 17 dz dt. Then divide both sides by 17. Have 40 over 17 equals dz dt. So 40 over 17 feet per second is going to be dz dt right here. So this is going to be the rate at which the man is letting go of the string when the length of the string is 170 feet. So we can write the statement down. So when the length of the string is 170 feet, the man lets out the string at a rate of 40 over 17 feet per second. So yeah, this should be the final statement of the problem, and then this should be the final answer. So thank you for watching.